Alright students, let's begin with 3-2, find greatest common factor and least common multiple topic today. We're going to begin by talking about prime factorization, and along with that we're going to make just a nice little list of things that are prime factors. Alright, so let's make a list of numbers that are prime factors that you can find through 100. Okay? One doesn't count because a number has to be divisible only by itself and 1. So the first one is 2. The second one is 3. The next one 5. The next one 7. 11. 13. 17, 19, 23, 29, 31, 37, 41, 43, 47, 53. We also have 59, 61, 67, we have 71, 73, we have 79, 83, 89, and I'm just going to add another little box down here. There's one more, and that is 97. These are all prime numbers, meaning the only thing that goes into them is 1 and itself. Alright, first thing we'll talk about with prime factorization is common factors. Okay? Common factors. And that is factors that are shared by 2 or more numbers. Factors shared by 2 or more numbers. Okay? Now let's look at prime factorization. We'll start with the number 48, and we'll make a factor tree. Now, as long as you start with numbers that go into it, when you factor it out completely to just the primes, you will get the same answer. So we picked 2 numbers that go into 48, and we'll start with 2 because 48 is an even number, and 2 goes into 48 24 times. Alright? 2's prime, so I'm going to circle it and not use it anymore. Now, I can keep doing this. 24 is even, so I know once again 2 goes into it, and 2 goes into it this time 12 times. 2 is prime, I circle it. And then I can factor out 12. Once again, it's an even number, so 2 goes into it, and 6. I circle 2 because it's prime. Almost done. And 6 factors out into 2 and 3, and both of those are prime. So I'll circle those. So then the final result would be, I start with the smallest number. The smallest number on here is 2. I'm going to write to the 1, 2, 3, 4th power times, I'm going to use a dot for times because we're getting into more advanced math now, 3. 2 to the 4th power times 3. Now let's do another one, okay? Let's do, we'll put it over here, let's do 64. And let's just show that you don't have to start with 2's, okay? I know that 64 is a perfect square, and so I know that 8 times 8 is 64. Now neither of those are prime, so I can factor it again. And I know, for instance, that 2 times 4 gives me 8. 2 is prime, I circle it. And once again over here, 2 times 4 is 8, and 2 2 is prime, so I circle it. And I can factor these out as well. 4 factors into 2 times 2, which both are prime. And 4 factors into 2 times 2, and both of those are prime. So now there aren't any numbers besides 2. So I'm going to write 2 here, count out how many they are. And there's 1, 2, 3, 4, 5, 6. So it is 2 to the 6th power. We can do several versions of this. All right? Let's look at another example here of prime factorization. Trying something a little different this time. Let's go with 60. We'll put it right in the middle here. And now that we've studied our divisibility rules, I know it ends in 0, so I know 10 goes into it, and 10 goes into it 6 times. Neither are prime, so I continue. Factoring out 6 is 2 times 3, and factoring out 10 is 2 times 5. And all of those are prime. So I'm going to circle those because I know I'm done. There's nothing left. And we start with the smallest number of 2. And we will write 2 squared times, there's only one 3, times there's only one 5. All right? So that's some examples of writing out my final product for prime factorization. So let's go on to something called greatest common factors. You can continue on this page, but I'm going to go to the next one. All right? And for greatest common factors, this is 3-2 continued. And I'm just going to abbreviate with GCF for greatest common factors. Now, we already talked about common factors. Those are factors that are shared by 2 or more numbers, okay? And then GCF, that is the largest of the common factors. Now, there's a lot of ways you can do this, guys. There really, really is. But I would like to demonstrate the easiest way, okay? We're going to go with the numbers we did on the first page, 48 and 64. Now, I'm going to put 48 here, and I'm going to put 64 here. Let's put a little equal sign after it, okay? Now, 48, if I were to write that out, think clearly, what is the prime factorization of 48, but I don't want to write the exponents right now because I'm going to show you a really cool trick, okay? And that is 2 times 2 times 2 times 2 times 3, because there were 2 to the 4th power times 3. And then the 64 is 2 to the 6th power, but I'm going to write it out 6 times. 2 times 2 times 2 times 2 times 2, and I need one more, don't I, to get 6. Now watch this cool trick. Guys, there are a lot of ways you can do this, but I have found this the easiest. Let me circle pairs top to bottom. I've got a set of 2's in each row here. I've got a set of 2's each row here. Here's another set of 2's, and here's another set of 2's. And I'm going to ignore what's left because there's no more sets top to bottom. And then I multiply across. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. And so I know the greatest common factor of 48 and 64 is 16. There's other ways you can do it, guys, but we do like to keep things the easiest, okay? Let's try one more example. This one's not as complicated, but just give you another visual. So let's try something a little simpler, 12, right? And let's try 28. Prime factorization of 12 is 2 times 2 times 3. Prime factorization of 28 is 2 times 2 times 7. All right, once again, look at these top to bottom. Circle my pairs, multiply across, and I get 2 times 2 across, which is 4. And that is my greatest common factor of 12 and 28. Now let's go on to the next part, and that is least common multiples. All right? Least common multiples. So in least common multiples, that's the smallest of the common multiples. And so I'm going to just draw a line under here. And we'll abbreviate this time, just call it LCM. So let's look here. Now, doing it a little different, let's go back to that prime factorization. I'm going to give you two numbers to work with, okay? Let's go with, can we go with 12, and we'll go with 8. All right? And this is a different trick for least common multiples, but works the same way using all the prime factorizations. 2 times 2 times 3 will give me 12. And 2 times 2 times 2 will give me 8. Now, here's the thing. I need to use everything. There's 3 2's here, which is more than the 2 2's there, so I know my final answer is going to have 3 2's because it's the most 2's in each one. And this row has a 3, and so I need to include the 3. And now watch this. 2 times 2 is 4, times 2 is 8, times 3 is 24. My least common multiple of 12 and 8 is 24. 24 is the smallest number both 12 and 8 go into. So I had to use here, here, and here, and so it means I already used 2 2's up there, and I needed to use this 2. So you get to use the most of what's in each row, okay? Now let's try another one for least common multiple. How about 16, right? And let's go with 12 again. Just make it interesting. Okay, so 12 we know from up here is 2 times 2 times 3, and 16 is 2 times 2 is 4, times 2 is 8, times 2 is, look at that, 16. Now I have the most 2's is 4 of them, and then there's a 3 in this row. So I know I've got to use 4 2's because that's the most of the 2's. And so that is 2 times 2 times 2 times 2, and then there's a 3 in this row because I've already used the 2's, times 3. 2 times 2 is 4, times 3 is 8. We can even go around here and go times 3 is 24, times 2 is, guess what? 48. So that is the least common multiple of 16 and 12. And that's how you find them.